Welcome back to mahasarkar.co.in. In today's video, we are going to learn about beats. Before starting with the lesson, consider some examples. When we consider the example of tabla, when two surfaces of tabla are strike, what will happen? Wave from first surface and wave from second surface overlaps. The overlapping of two waves is called as interference of the wave that we have learned in the wave optics. Okay, so during the overlapping of two waves, the resultant intensity is increases and in next interval it is decreases. Okay, so we say that there are two types of interference are produced. So overlapping of two waves, overlapping of what? Two waves produces what? Interference. Interference of the wave. Okay. During interference, intensity increases also and then again decreases also. So what we get is the result is the impact of increase and decrease intensity alternately. So when two sound waves overlap, in the interference of two sound waves, resultant intensity increases at instant and then again what? Decreases also. Where the intensity increases, the point is called waxing. The point is called as what? Waxing. And where the intensity decreases, the point is called as waning. Okay. This alternate waxing and waning are heard by our ears and then we say that we have heard the beats. So alternate waxing and waning when forms, we say beats are formed. Beats are what? Formed. Okay. This alternate and waxing and waning when formed, we say beats are formed. Number of beats per second is called as the frequency of the beats, and time required to complete a beat, means one waxing and one waning or two consecutive waxing, is called period of the beat. Okay, we are going to show here that during formation of beats the frequency for waxing and waning is same. Okay, so to find out that, consider two simple harmonic progressive waves. Consider two simple harmonic progressive wave with slightly different frequencies but same amplitude. Their frequencies are slightly different. So let first wave is given by y1 equal to a sine 2 pi n1t. Second wave is given by a sine 2 pi n2t. Okay. So according to principle of superposition, total displacement is what? The sum of individual displacement. We have already learned this in a previous lectures. So substituting this, what we are going to get here? A sine 2 pi n1t plus a sine 2 pi n2t. A is common, sine 2 pi n1t plus sine 2 pi n2t. Now the same type of formula we have used in previous articles also. So I will call this as C and this as D. So sine C plus sine D. We know the formula. I am going to write it directly now. So it is 2, A is as it is 2 times sine C plus D, means addition of these both. 2 pi and t is common, so 2 pi in bracket n1 plus n2 upon 2 into t. I just adjusted the term. 2 pi is common, t is also common. So 2 pi upon 2 pi into t is common, n1 plus n2 divided by 2 into cos of 2 pi again common, n1 minus n2 upon 2 into t. Just let me check whether it is visible or not. Okay. Okay, it's visible, very margin, corner. Okay, so let's go with the next part. Simplifying this, I will write this first term and then I will write the next. So here it is like 2a cos 2 pi n1 minus n2 upon 2 into t into sine 2 pi n1 minus n2 upon 2 into t, sorry, plus. Okay. Now here, see, if n1 is the frequency of first wave, n2 is the frequency of second wave. So addition of both divided by 2. So here, let n is the average frequency and that can be given by what? n1 plus n2 upon 2. Also, say r equal to 2a cos 2 pi n1 minus n2 upon 2 into t. So it is what? Resultant amplitude. It is what? Resultant amplitude. So if I substitute this, what I am going to get is y equal to, instead of this entire term, I am going to get r sine 2 pi, this bracket will be n into t. So what we can conclude that when two sound waves of slightly different frequencies overlap, the resultant wave is also simple harmonic progressive wave where it gives r as the resultant amplitude and n as what? The average frequency. Here, when waxing will be there, sound will be maximum as the resultant intensity is added up. When waning will be there, sound will be minimum as the resultant intensity is what? Subtracted or opposed. Okay. So in that case, we are going to find out the conditions for waxing and waning. So let's find first condition. Condition for waxing. What is the waxing? Point which has maximum amplitude is called as what? Waxing. Okay. To see this, now what is the maximum value of amplitude? Resultant amplitude is a function of cos theta. So here, to get this function maximum, I should write r should be equal to plus or minus 2a. Same assumptions we have used in the first article from this lesson. Substituting this value, 2a cos 2 pi n1 minus n2 upon 2 into t equal to plus or minus 2a. See, this 2a will get cancelled. So what will remain? Cos 2 pi into n1 minus n2 upon 2 into t equal to plus or minus 1. This 2 will cancel. So I will write like pi into n1 minus n2 into t. This is complete cos theta. So this 2 get cancelled. Okay. So theta equal to what? Cos inverse of plus or minus 1. Just simplify. Pi into n1 minus n2 into t can be equal to, what is value of cos plus 1? 0. Minus 1 pi, 2 pi, 3 pi, 4 pi and so on. So what we will get? T equal to first value 0. Now pi divided by this, na? Pi divided by pi into n1 minus n2. 2 pi divided by pi into n1 minus n2. Similarly, it will go. Okay. So it is 0. Pi get cancelled. So 1 upon n1 minus n2. 2 upon n1 minus n2. Similarly, you will get 3 upon n1 minus n2. So the first waxing will be formed when the time interval is what? 0. Sound will be maximum. Then for next time interval, it will be what? Again waning and then again it will be maximum. So first forms here, second forms here, third forms here. So this is first waxing, second waxing, third waxing. So difference between these two will be period of the waxing. So period of waxing can be equal to t equal to, what I will get? This minus this or this minus this or this minus this. So याच्यातनं याला minus करा, it will be like 1 upon 1 n1 minus n2. याच्यातनं करा तरी same. 1 upon n1 minus n2 will be the period of waxing. So at the same time, I will write frequency of waxing. Frequency of waxing is what? N equal to 1 upon t. म्हणजे काय मिळणार आहे n1 मायनस n2, याला कॅपिटल N लिहितो मी. ओके, these are the conditions for waxing. So if you find the conditions for vanning, then for vanning, condition for vanning मी शॉर्टकट मध्ये लिहितो, तुम्ही ट्राय करा. बघा, वॅनिंग साठी R शुड बी इक्वल टू काय पाहिजे, 0 पाहिजे. म्हणजे हे सगळं सेम राहील, इथं फक्त 0 होणार, इथं 0 होणार, इथं 0 होणार. म्हणजे ही तर टर्म इथपर्यंत सेम आहे, मी डायरेक्ट इथून लिहितोय बघा. ओके, सो पाय इंटू n1 मायनस n2 इंटू टी, कॉस इनवर्स प्लस और मायनस, कॉस इनवर्स डायरेक्ट 0, प्लस मायनसची गरज नाही. कॉस कधी 0 असतो, पाय बाय 2 ला, 3 पाय बाय 2 ला, 5 पाय बाय 2 ला आणि सो ऑन. पाय कॅन्सल झाला दोन्ही साईडला, थोडं सोपं करतो. n1 मायनस n2 इंटू टी इक्वल टू 1/2, 3/2, 5/2, दोन्ही साईडला पायने डिवाइड करून टाकलं. सो टी इक्वल टू काय मिळणार, 1/, हा डिवाइडला येणार 2 इंटू n1 मायनस n2, 3 डिवाइडेड बाय 2 इंटू n1 मायनस n2, 5 डिवाइडेड बाय 2 इंटू काय मिळणार n1 मायनस n2. अशा करत करत हे मिळत जाईल बघा. सो हिअर देअरफॉर पिरियड ऑफ वॅक्सिंग काय मिळेल, सॉरी पिरियड ऑफ वॅनिंग टी इक्वल टू, या दोघांमधला डिफरन्स बघा, याच्यातनं याला मायनस करा, 3 मायनस 1 2, आणि हा 2 कॅन्सल होणार, मी डायरेक्ट लिहितोय बघा, तुम्ही चेक करा, हा मिळणार. देअरफॉर फ्रिक्वेन्सी किती मिळणार, n इक्वल टू n1 मायनस n2. फ्रिक्वेन्सी सुद्धा सेम आहे, कोणा एवढी, वॅक्सिंग एवढी. सो we can show that when two waves overlap, they can produce maximum sound when we call it as what, waxing. When two waves are overlap, they can produce minimum sound also, that we are called as what, vanning also. Alternate waxing and vanning give rise the concept of beat, and this is the analytical method to study the concept of beat. I hope you understood today's article. Here we have done with the lesson also. Thanks for watching mahasarkar.co.in. Have a nice day and keep watching next videos. Thank you.